Okay, so hello all and welcome to this session on the machine learning operations. My name is Shubha and I am an AI scientist at CellStrat Lab. So today's session is about machine learning operations. So this will be a hands-on workshop where you can experiment and run the code yourself on CellStrat Hub. We will be using two tools. The first one is weights and biases and the second one is MLflow. So we'll be incorporating both of these tools to construct an end-to-end pipeline, and I'll be sharing the code with you, and you can sign up into CellStrat Hub if you already do not have an account, and you can run the entire program yourself. So I highly encourage everyone to give it a try today to do the hands-on on CellStrat Hub. Moving on to machine learning operations, MLOps can be kind of broadly classified into three subparts, or rather three different parts where it is easier for you to kind of manage and handle the thing. So the first part will include building an end-to-end ML pipeline. So once the pipeline is built, you will have to deploy the pipeline into a scalable model. And after deployment, we will be talking about ML scoring and ML monitoring. So it is, I will not be able to cover all of these things in today's session. So today's session, I'll just be doing the first part of it, where we are building an end-to-end ML pipeline. The other two parts will probably try to cover it in later sessions. So I would like to give some kind of information about how this workshop will be going. We will be doing the first part of it, that is building an end-to-end ML pipeline using weights and biases and MLflow. This is different components. Each of these components, I will be giving a short demo on how to execute those components. So you need not worry about executing those demos. You can just see how to execute them and try to understand the code better. And once we cover all of the components and all of the demos of each of the components, we will build an end-to-end pipeline, and that pipeline you can run it on CellStrat Hub. And any questions in between, please do post it on chat, or kindly feel free to unmute yourself and directly ask those questions. So with this, I will just move on to what are the topics that we will be covering for today. So as I told, since this is the first part of MLOps, we will just be focusing on orchestrating the end-to-end pipeline and building the same. And going on in future classes, probably we will look at deploying this pipeline in a scalable environment, and the last part will be monitoring your model in production. In case there is some kind of data drift or model drift, the model needs to be monitored. So today's agenda will mainly cover all of these concepts. We will see MLOps being used in three different levels in organizations which are at different levels. To perform MLOps, a lot of different tools are available. We will look at the different tools that are available in the market, and we will be choosing, as I already said, WNB and MLflow. And we will try to understand what are components and artifacts. We will do orchestration using MLflow, and our regular ML workflow that we generally have. We first start with data exploration, and you validate your data, and then you build your model, and finally you deploy your model. So this is the general pipeline that we have seen. We will learn how to do each of these things using one of the tools. So let's begin. This division where I'm telling that you have three different types of MLOps, I've taken it from a blog that's written on Google Cloud Platform. According to them, MLOps can be broadly divided into three main parts, where you have level 0, level 1, and level 2. Level 0 is your manual process, where generally this is done where your team is trying out machine learning or data science at a very small level, or they're just trying to experiment if something is going to work. And the team size is kind of really small. You just have 1 or 2 data scientists on the team. In this case, you are still in the experimentation phase and you do not need any kind of MLOps. A simple Jupyter notebook might suffice. If you have participated in any kind of competitions on Kaggle or something like that, you would have also used Jupyter notebooks. You do not bother about reproducibility or something like that. So in this scenario, there will be no awareness of ML monitoring. And you just create either you just have a simple notebook, or you just have simple Python scripts to run your code. Yeah. And in level 1, you will have what level 1 is generally used when you have a small team of data scientists. So maybe some 5 to 6 data scientists are there, and each of them, you need to collaborate with each other. So in the first case, what happens is you will not be able to collaborate with each other. Maybe you worked on, you have a simple data set and you tried one particular model and your colleague tried some other model, then you will not be able to collaborate if you are doing it on Jupyter Notebook. But in the second level, maybe a few, you have a small team of data scientists and you need to collaborate. So in this case, what happens is all of your code artifacts and experiments, all of these things are tracked, and you try to build a reusable pipeline so that you are trying to do several experiments on the same data or different types of feature engineering or exploratory data analysis. You need to repeat the same over and over. So the entire pipeline that you have, you will try to automate it or orchestrate it. And the model that you have, probably it's monitored only in production. Maybe in your development and staging environment, you do not do a model monitoring. Only the model monitoring happens in production. Here you can include some amount of CI/CD. CI/CD is continuous integration and continuous deployment. But CI/CD is again available only at the model artifact stage. The final level is probably used at very huge organizations which have really a lot of data scientists in a team who are working together, and you implement CI/CD and also what is called continuous training. So this is kind of a difference between the normal DevOps and MLOps. So what happens is the entire pipeline itself, the entire pipeline that you have built, that itself probably needs to be deployed. Whereas in this case, it can be that only your final model is being, you're implementing CD only for your final model in production. Whereas over here, your entire pipeline you need to implement CI and CD best practices. So let's kind of take a look at it in slight more detail. Over here, everything is manual. You have your data preparation, your model training, and model evaluation. Everything is manual, and you need to establish connection or relationship between these things. Maybe you're trying it on some cloud or on your local laptop. You will prepare your data and you store it at one spot, and you need to pick it up from there, train it, and pass it on to model evaluation. So the link or the connection between all of these three things will be manual. Yes, so okay, fine. When you come towards this MLOps part of it, you just have the trained model. You would have trained it once, and you will just place it in the model registry, and you will create an endpoint for that model, and that will be used for predictions. So in this case, what happens is there is no concept of retraining in case there is some kind of drift, or there is also no kind of automation. So all of these steps are manually executed. Moving on to the next level, there is some kind of automation over here. As you can see, there is an orchestrated experiment. So all of these things, this is in the test environment, and then that same thing gets moved to your production environment. All of these things are orchestrated. So it is kind of a pipeline. You just pass in your data to the first step, and then you get your output model at the final model at the last step. So this entire process is orchestrated over here, and you store your code in a code repository, something like GitHub or something. And your model is again this pipeline. You try to deploy it into production, and the model, you do a CD serving of your entire model. So in case your final end model changes, this model gets automatically deployed onto your server, and predictions are made on top of that. So there is some kind of automation over here, and you do store your code in a source code repository, and you implement some kind of CI or CD. So here there is a bifurcation between ML and Ops. So we know the difference between what a data scientist does and what an ML engineer does. A data scientist is mainly involved in all of these activities. So we do a lot of experimentation and try to train it on different models and hyper-tune those parameters. And once you kind of finalize on the best model based on all of your experiment, you just give that model to a model and place it in a repository, and there ends the job. So the ops team from there has to pick up the finalized model and try to deploy it, and building a scalable infrastructure and all of those things is handed off to the ops team. The final level which is kind of implemented in kind of large companies with huge number of data scientists, what happens over here is the entire orchestrated experiment or this kind of comes where this kind of helps the data scientists to rapidly orchestrate and rapidly do experiments. So experiments may not always be in terms of tuning hyperparameter. It can also be like they are trying out different features, or they're trying out different EDA or different data validations and different techniques. So all of that entire thing itself gets this entire thing itself is integrated and deployed to your production environment. So when you say CD, which is continuous deployment, what happens is you have a model, a trained model. This trained model will automatically get deployed into your server. So this is the concept of CD. But what happens in huge organizations is this entire pipeline, starting from when you start from feeding it data all the way till it produces the model, you need to rapidly experiment with this pipeline. So this entire pipeline itself follows the CD architecture. So the entire pipeline itself gets deployed into production. And over here, there is heavy performance monitoring and model monitoring as well. Model monitoring is kind of a very important concept if you're doing large-scale production deployment. In case there is a data drift or a model drift, it has to be retrained. You'll have to add links to retrain all the way and then come up with the retrained model. So at a high level, MLOps can be used in organizations at different levels based on in what level they are. And this is kind of an introduction. So I will pause here for a minute to understand if any of you have any questions. Okay, so yeah, sure, go ahead.
Yeah, please feel free to ask questions.
Okay, probably you can ask at a later point. Let's move on over here. Some of the tools that are available is, we know that for code tracking, you have GitHub. Other alternatives are you can use Bitbucket or GitLab to store your code. You have to do experiment tracking. Experiment tracking is nothing but playing around with hyperparameters. Today we will be using weights and biases to do experiment tracking, but you can also use MLflow, and Neptune is an alternative to do the same. Artifact tracking. So everything, any output that comes from a component is called as an artifact. And again, we'll be using weights and biases for artifact tracking. You can alternatively use MLflow. Model repository is where you place all your models. It is kind of a cloud-based repository where you place all of your trained models, and you pick one of the models and mark it as the final model. And ML pipelines. ML pipelines is the orchestration process. So you have different stages in a data science life cycle or an ML life cycle. You start from data preparation, validation, and so on. All of these things have to be orchestrated. So we will be using MLflow for orchestration and Hydra for to manage your parameters. You can also use Kubeflow as an alternative to build ML pipelines. For environment, we are using Conda. You can also use Docker. And orchestration, as I told, we are using MLflow and Hydra. And for modeling, we will be using sklearn. Today, you can I'm sorry, there's an error over here. You can also use PyTorch, and an alternative is TensorFlow or FastAI or any other. You can build your own neural network and you can execute that. But these are some of the things that we will be trying out today. So before we move on, I wanted to mention a couple of, give a quick intro about what some of these tools are. Weights and biases is mainly a cloud-based repository which helps you store your artifacts, store your data, store your models, and also experiments, different hyperparameter tuned experiments. All of these things, it allows you to store it in a cloud-based repository. Weights and biases offers these things, but it does not offer you orchestration. You cannot combine different steps together using weights and biases. MLflow also gives all of these things. So you can do experiment tracking, you can store your artifacts and all of these things. MLflow also offers you orchestration. And Hydra is Python-based platform which helps to manage your parameters. Basically, you would have seen that in any ML code that you write, there will be lots of parameters, and if you are running it via command line, it is kind of difficult to track all of your parameters. So Hydra, using Hydra, you can kind of define all of your parameters in a config file, and you can use that in your program. So Hydra is, I think it was given by Facebook. I'm not sure. I have to verify that once again. And the other thing that I wanted to mention is you can do it alternatively. We have just used one tool in today's session, but you can use something different. And the process is kind of very similar. So you do it once and you understand one of the tools, the knowledge can easily be transferred to any other tool. The concept is the same. It's like we are familiar with AWS, and then we kind of understand how Azure or GCP works. It's not that you have to know everything about it. So it is more or less the same. Moving on to some of the terminology that will be used in any MLOps data science lifecycle. A run is the basic unit of computation. So if I'm doing one round of exploratory data analysis, I can call it as a run. If I am trying to tune hyperparameters and kind of I use one set of parameters like learning rate as 0.01 or something, then that is one run. And if I change the learning rate to something like 0.001, then that will constitute another run. And experiment is if I want to group one or more runs. Let us say I have a problem, and in this problem, I have a data set. I am trying different models on this data set. Let's say I try random forest and I also try XGBoost. So with random forest, I will do a lot of hyperparameter tuning, maybe 5 or 6, and with XGBoost also the same. I can categorize this as one set of experiment and this as another set of experiments. You can also compare between experiments. And a project is a heterogeneous collection of all runs, experiments, and artifacts related to a specific goal. So if I'm kind of building a computer vision project, I can have that as a project. And simultaneously, if I'm also working on some NLP stuff, I can define that as the second project. So my computer vision project will probably have a lot of experiments. I'm trying different architectures, different CNN architectures, and different runs. And my NLP project is a different project, and it can have its own set of experiments and runs. Artifact, we generally tend to understand artifact as the model artifact. So you train your model over here, and whatever the trained model that comes out of that is called as artifact, but that is not always the case. The output of any component, for example, let's say we are doing EDA over here. After we do EDA, the next thing is we do some kind of feature engineering. Then we do what is called as data cleaning. If something that comes out of each of these components, after we do EDA, maybe we have some kind of a report that's generated, and after we clean the data, we have a data set or a CSV file that's generated. And after we do modeling, there is a final model that's generated. So the output of each and every component of your flow, each of those things are called as artifacts. So are we clear till this point? Shall we move to the next concept? So moving on, I will show you, this is a simple code snippet from weights and biases to just understand how to put in an artifact into weights and biases. Over here, what we do is, this is the code that we execute. You do not have to worry. I'm just kind of trying to show the code over here, but later on during our hands-on, we will be doing the same. We will be doing the same. You will kind of be repeating the same. So when we are doing the hands-on, for you to kind of be familiar with the code is why I'm trying to put here. You can pip install WAN-DB. You can pip install WAN-DB, and once weights and biases, and once that is done, you just import that and you initiate a run using the WAN-DB.init. You can give it a project name and a group name. Group is nothing but your experiment, and a job type just as a description to tell what you're trying to do. And you can create an artifact and add that artifact and log the artifact. So probably after you do some kind of feature engineering or something like that, you can log this artifact, and this artifact gets stored in your weights and biases account. And whenever you want to, in the next step, whenever you want to use your artifact, you just say use artifact, and you get that file, your CSV file, and you can put it in your data frame, probably to load it into your model or something like that. So that is an introduction about WAB, and we'll be looking more of it in our code. Orchestrating your code with MLflow. So we have a lot of we have our code, and how exactly do we orchestrate it using MLflow. So when you're trying to orchestrate it, you will have to create a folder with 3 specific files. The first one is your code. This code is what exactly you want to do. Maybe you're trying to do feature engineering or EDA or whatever. You will have to give an environment definition. This is generally a conda.yml file, which says what are the dependencies that are needed, pandas, numpy, or whatever. And you will have a project definition. So MLflow will kind of look at this project definition and see what has to be executed. So let us quickly take a look at an example of how this will work. I will go to MLflow over here. And as I told, you will have 3 files in your folder. You will have a conda.yml file. You will have your ML project file. This ML project does not have any extension. And finally, you will have a download data.py. So if I look at my conda.yml, you just give it a name and from where to download. So the channels to download is generally Conda Forge. And what is it that you want to download? We need a requests library, and these are the libraries that can be installed using Conda. But then there is WANDB is not available on Conda, so you'll have to do a pip install WANDB. So since you have a pip install WANDB, you just specify it like this. So this is basically your requirements file telling you what are all the packages that are needed. And looking at my ML project file, you give it your Conda environment and a name, and you specify the parameters that are needed. Like your parameters can be file URL, the artifact name, artifact type, and artifact description. And you will specify a command that has to be run. For example, Python download data.py and all of these parameters. So what happens is, when you run this particular package, it knows that this is the entry point. So this is the main entry point. You can also have additional entry points in case that is a requirement in your project, but you specify your entry point, what are the parameters used by your entry point, and what is the command to be executed. So I just have an execute over here. So I can go to...
Yeah, if folks need time to catch up, let us know.
Yeah, sure.
Those who had requested CellStrat Hub account while on this call, their accounts are being sent by email. So you can log in and follow through in a hands-on fashion as well on our CS Hub platform.
Yeah, so here you go. So this is the same file that I showed you. You have your ML project, you have your conda.yml, and you have these. Once you run, all of these additional folders will be created, ML runs and WANDB, and execute.text as I have just created it to get the command for execution. That's nothing. And when we looked at this download data, you just run it as Python download data.py and pass all your parameters. And if you look at what exactly is in download data, this is not doing anything. See, WANDB.init, it is trying to create a new project, and it will create an artifact, add that artifact, and load that artifact. So this was these were some of the commands that I showed earlier on the PPT. You have to just create a WANDB init, initialize the project, create an artifact, and load the file. So this is the structure of it, and this ML project already has your Python download data.py. So what happens is all that you have to do over here is you should simply say MLflow run dot. So the minute you say MLflow run dot, okay, you will have to pass all of those parameters. So I forgot that. Yeah. MLflow run dot -p, I have a file URL. So from scikit-learn, it is trying to get your iris.csv. There is an artifact name over here, and there is an artifact type and an artifact description. So you just try to run this file, and this is going to take some time. I have already logged into our WANDB account, and you can see that it is all, it would have logged in, it would have created a new project, and that artifact will be logged in. So I can see that exercise 2 was the new project that I created. And here is the run name. So generally WANDB gives its own run names if you do not specify anything, which is a unique name. And once you move into artifact, you can see that iris latest artifact is stored over here, which is a CSV file. So once you orchestrate it using MLflow, all that you have to do is you have to just run MLflow run dot with the parameters, and it's just going to run that way. Shall I move on to the next part? So now that we saw how you have a simple MLflow, now you saw that how you have a simple MLflow project with just 3 things. This is how you build an MLflow pipeline. So every MLflow pipeline folder, it will have its own conda, main.py and ML project. And main.py is the ML project will run your main.py, and inside this main.py you can call the subcomponents like download data or remove duplicates. And each of the folders components that you have over here, each of the components that you have over here, it has to each of the components that you have over here, it has to follow the same format. Like you need a conda.yml, you need an MLflow project and a run.py. So it is the same thing that has to be followed. So let's look at that example over here. And before we go into this example, I will just try to tell something about Hydra. So Hydra, as I told, it is Hydra is a parameter management software kind of Python-based framework that is available. So if you look at this that we wrote over here, the command to run this, you will have to pass your own parameters over here. But as you progress in your project, the number of parameters will drastically increase. You will see that in our own hands-on workshop today. This will kind of drastically increase, and we will not be able to it is not possible to pass it via command line. So what we generally do is we use a config file to do the same. And going to that, you create what is called as a config.yaml file, which is again a kind of YAML file which over here like this, and you give your project name and experiment name, and within data you give your file URL. So all of this parameters that you have, you will specify it over here. And if you look at your main project over here, all that you have to do is you will simply say Python run the project echo and Hydra options. So you go to your main project and look at it once. You will have to add this decorator over here at hydra.main config name is equal to config. So once you add this decorator over here, your entire config file that you saw. So this was the config file with all of your parameters. All of those things can be easily used in your program like this. So you have to just add a decorator, create a YAML file for your config, and all of those create a YAML file for your config, and all of those parameters can just be accessed once you have this decorator. And over here you can see that this is our main program. We have 2 runs. We have MLflow first run and MLflow second run. MLflow first run is download data. MLflow second run is process data. So the 2 things that we saw in our screen, this is how you organize it. In your main project, you say run MLflow download data and MLflow process data, and you create subfolders in this way, and it executes them in that order. So this is how you will be building an orchestration pipeline. Any questions over here?
So how is Hydra different from ArcParse-Quick?
So ArcParse is ArcParse. What will have? I am not aware of what is ArcParse-Quick, but general ArcParse. What will happen is all of your parameters you have to pass it via command line. It is sometimes if your parameters is kind of really large, you will not be able to pass all of your parameters via command line. So it is kind of a parameter management tool. You will see in our hands-on exercise that we have quite a lot of parameters, and it is not possible to pass all of those parameters over command line. If I'm not familiar with ArcPass Quick, if it is kind of another tool for parameter management, yes, it can be used. So can we move to the next part?
Are folks doing the hands-on part or just listening in?
No, this is not hands-on. I'm just showing the code just to familiarize. Okay. I have a complete hands-on session where with full instructions, which I will be sharing along with my GitHub repository, then they can experiment it.
Got it. So they have to have a CellStrat Hub account, right, Shubha?
Yes, they have to have a CellStrat Hub account. You can run it on your laptop, but it kind of needs a lot of installations. So, but I have instructions clear for how to use it on Hub. So in case you do not have a Hub account, it is very simple to create one. So please go ahead and create one. I encourage everyone to try on the hands-on so that you get a feel of how the orchestration is done and how an end-to-end thing works, and you will be able to visualize the results yourself on WNB website. I will move on over here for exploratory data analysis. So exploratory data analysis is kind of simple over here. So this is a set of images that I have, and all of those images are stored over here. And in WAN-DB, what we do is we are trying to create a table. So WAN-DB helps us visualize our data as well. Now, whenever we do exploratory data analysis by ourselves for some kind of a POC or competition, what happens is we have all the data, and we do a visualization in Jupyter Notebook, but it is kind of difficult for us to share it with the other team members. But over here, WAN-DB allows us to create a table for you to kind of do exploratory data analysis and visualization, and it helps you to share that information with others. So I will not bore you with a lot of these APIs that are available. You can always look into WAN-DB's API, but all that I'm trying to tell you over here is we are trying to visualize a computer vision data set, a set of images with classes, image segmentation. And over here, I am using the WAN-DB table, and I will create an artifact and load that artifact into WAN-DB. So what we'll do is we'll get into WAN-DB to look at our output on how this has got generated. Okay, so I'll go to artifacts over here, and the raw data artifacts, the data is stored over here. And we can go to files. All of your images, labels, and media is stored. I will go to this table that was just created using the code. The file name, the image name, and the background. So this is kind of an image segmentation problem that is happening for different backgrounds that are there. So it is trying to tell us that this particular image has a background. It has road, but it does not have traffic light. It has some traffic sign. There is a person, vehicle, and things. So you can just add this to report. And if your team of data scientists is kind of if your team of data scientists is all of you are working on a shared project, it's easier for you to share this exploratory data analysis with them. So this is just kind of an example that I'm trying to give over here. You can check out WAN-DB's examples a lot. So this is also telling us what are all available over here. You can check out WAN-DB's example. Such kind of exploratory data analysis is available with NLP, with audio data, with videos, and you can create interesting visualizations even using tabular data. So you can incorporate charts over here to understand the classification, or what do I say, if there is an imbalanced data set, or the percentage of classes available in a classification task. So a lot of you can play around a lot using WAN-DB table and WAN-DB visualization to create interesting reports and share the EDA with your project team members. So there are a lot of images over here, and all of those have been created and put across on a table. But you don't have to worry too much about the code. It is just a simple API that we are calling to understand this visualization. Any questions here?
So we need to register there, means WAN-DB site?
Yes. I have instructions. I know that it is kind of, everyone is eager for the workshop. Just this one, and sweeps is something that I want to explain. Experiment tracking and sweeps, I just want to quickly show that. And once I'm done with that, we can spend quite some time on hands-on. That will be more interesting. Yes, I have instructions. You have to it is just sign up into WAN-DB account and you can do that. Data validation is kind of a very important step compared to the regular DevOps practice. I am just giving a brief on the two different types of data validation that you generally do, but I am not getting into the code for this. Lot of testing tools are available in Python, like PyTest. You can incorporate PyTest to do the data validation. So why is data validation important? You will have some set of training data and you have production data. If the production data is not matching, the number of columns is not matching, or the distribution is not matching, something like that, you will not get accurate results. So data validation step is an important component that has to be incorporated. So it will also be used for continuous integration. Before you put in your code or your data into your pipeline or into your source repository, you will have to do data validation. Deterministic tests are simple. You're just checking the number of categorical values or number of columns. So if you're doing one-hot encoding or something like that, if your train data has 4 categories, you will have 4 columns when you're doing one-hot encoding. Whereas if your production data just has 3 categories, then you will just have 3 columns in your production data, which is going to result in error. So it is important to check the data types and data columns and other things in your train and production data. So those are deterministic tests, and non-deterministic tests will be statistical tests. If you're trying to use salary as a feature and that salary is coming from 2 entirely different distributions. So in train data, it is coming from a distribution where mean is just 10K, and in production, it is coming from a distribution where mean is 1 lakh or 10 lakhs. Then that is going to have impact on your model performance. So any kind of statistical tests that you do, either for mean or standard deviation or correlation, all of these things will be categorized as non-deterministic tests. You can use any tool such as PyTest or something to incorporate these tests in your orchestration pipeline. Finally, we'll move on to experiment tracking. This is generally called as sweeps in any MLOps terminology. So we will be doing sweeps using Hydra. You can also do sweeps using weights and biases. So let's quickly look at sweeps using Hydra. Training and experiment tracking. So our config.yaml file over here. As you can see, as I told earlier, you will have lot of parameters. So this is the data that you're having, and you will have multiple parameters over here, and all of these parameters, it's difficult to pass all of these parameters via command line. So this is your config file, and you are just you're calling your main project, and main project is calling your random forest project. And if I look at my main project over here, this is just MLflow.run called random forest, and for config you're giving the train data, and the entire model config itself you're passing it as configuration. So sweeps using Hydra, how do you execute it? So MLflow run dot is to run your program. It will use all the parameters that were specified in your config file in case you want to override any parameter. So let's assume that we want to override the max depth parameter. You can override that parameter like this. You can say max depth is in range of 1 to 10 all the way increment by 2. So it will try for 1, 3, 5, 7, and 9. So it will try for all of these things, and when you do this, it will create different runs for each of the, it is going to create different runs for each of your different set of parameters. So you define your config.yaml parameter, and whenever you're trying to execute it, you can just execute it like this. I would also like to show one of the, okay, we can look at the results of this, that was this training and experiment tracking demo that was done. Okay, just give me a minute. I'm not sure. I'll just check on this and get back. Looks like some time back. Okay, sorry, I was in the wrong folder. It's exercise 11. Yeah, here we go. So all of your, our code over here is logging all of these as artifacts. It's uploading all of these things as images. So the feature importance for each of the hyperparameter is logged in. So if you can see, there are different features over here, and feature importances for each of these experiments that we have done is logged in. The confusion matrix is also logged in. You can click on table over here to look at the different experiment results. You can click on columns to get more columns, but this is kind of confusing. So just for simplicity, I have just few columns over here. You can include more columns if you want to see on that report. The AUC score and max depth. So max depth was the parameter that we tried to tune. So let us see how does your AUC score vary for different max depth. So for different sweeps, this was the max depth values, as I told, 1, 3, 5, 7, 9. And this is the different AUC scores that you have. So you can just click on AUC score and say sort descending. So this is the one with highest AUC score, and probably that is the, this is the one with highest AUC score, and probably we will choose that as our final model. So this is how you can visualize different sweeps within by executing it via Hydra. And I just want to show you one more example over here. Okay, I don't have it. Okay, let's move on to, we can go to the hands-on session. In the meanwhile, when you, however, our hands-on program will take some time to run. And while you are running it, I can just look at one more interesting experiment sweeps that was an example from weights and biases. Yeah. So here is my repository. MLOps workshop is my repository. I will just copy and paste this. I will just copy and paste this on chat. And if you go to this repository, you have instructions that are ready. So we can take some time to execute this over here, but I encourage everyone to try it out on CellStrat Hub so that you'll get a feel of how an end-to-end project can be orchestrated and implemented. In this main repository, there is a file called as instructions.txt. So I have given clear instructions on how to run this program. So we will create a new CellStrat Hub account if you already do not have one, and we can start Workspace and launch Jupyter. And once you have launched Jupyter Lab, create a new folder and clone this repository into that particular folder. I have already launched my workspace. So this is Vivek has already pinged the link to CellStrat Hub. And creating an account in CellStrat Hub is very simple. So please create an account with your email ID and launch workspace. Start workspace. This will kind of take a couple of minutes, and then you just launch Jupyter Lab. Since I have already done it, I will just stop here for a minute to give chance for you to execute the same. So please let me know once that is done.
Can you repeat what we have to do? So we go to your GitHub account then.
On my GitHub account, there is this file called as instructions.txt.
Mm-hmm.
So all the instructions have been specified in detail over here. First step is create a new CellStrat Hub account if you do not have one. Start Workspace and launch Jupyter Lab, and create a new folder and git clone this repository into your new folder.
Okay, so we have to create a new folder in the terminal.
Yes, you can create a new folder in the terminal or directly using the UI.
Yeah.
So I have created this new folder over here called MLOps Workshop, and I have git cloned the repository into this MLOps Workshop. So at this point, can I get a response from the audience if you have any questions, or if you have started you are able to start on the workshop session over here? So creating workspace takes 3 to 4 minutes, but then I encourage you to create it and experiment, run the code today so that you get an experience of how it works.
Yeah, I'm starting my workspace.
Can you run it in Colab or Jupyter? This requires a couple of things. MLflow run dot especially, that needs to be run from a terminal. I am not very sure on how do you do it on Jupyter Colab. You can do it on your local instance as well, but you will have to install some packages. If you have Anaconda and other things installed, maybe you can try it on your system. But if you can just give it a try on Hub. So Vivek, Prasad over here is telling that it's taking quite some time for him to create workspace.
Yeah, it takes 3 to 5 minutes. That's normal.
Let me know once the first 4 steps on instructions are complete.
Meanwhile, we are continuing to create accounts for CellStrat Hub, whoever is requesting.
If the first 4 steps are done, shall we move to the next steps? Okay. Supir is having an error. So do you want to unmute and tell me? Okay. So git clone. I think it is just git clone and the repo, right? I have already pinged. I have pinged the URL for my repo. Just try to git clone it. Or if you're not able to clone it, you can fork the repository to your own GitHub folder, GitHub account, and then from there also you can git clone it. If you're not able to clone my repository. But it's just git clone and the repository name. I think that should work. So Supir, if you're not still able to do, let me know, I can help you. Can we move to the next set of steps? Is everyone done here? Okay.
Sukhbir wants to share screen.
Yeah, sure. I will stop sharing. You can go ahead and share your screen. So, not on the console. Just, yeah, go there. You are doing it. Yeah, you'll have to open terminal. Open terminal. Correct. Console one on top. Not that. Open terminal, just not that. Come down, terminal, down. Left, first one. Yeah. No, it's white in color. You're opening a console, I think. Yeah, come down, white in color, terminal. Yes, that's right. Over here itself, okay. Okay, yeah. So click on the folder icon. Can you click on the folder icon in the left? Yeah, so you have created an untitled folder. Can you just go up? But I think your thing got created right on the root folder itself. Now, can you go one folder up, level up? Yes, that one. No, that is too, sorry, no. If you can click on that folder button, yes, that one. Yeah, MLOps workshop and all of these things are there over here. Yeah, you're good. So in the right-hand side, you will have to navigate to this folder. So in the right-hand side, yeah, can you just do an LS? Just do an LS, we'll see where you are. Yeah, so CD MLOps workshop. Correct, okay, yeah. Okay, yeah. You can just wait over here for a minute. Let's just, I think I had a couple of other questions.
So can
You
you
can
stop?
also, yeah, sure. Who is this?
I'm Subir.
Yeah, hi Subir. You can stop sharing, yes. No, I think you're good now. We will just see where others are and we can proceed.
Thank you, ma'am.
So, no problem. So Monima, Jupyter Notebook is not launching. So you, for now, probably you can just create a new folder and git clone, create a new folder and git clone the repository into that folder. If everyone is done with first 4 steps, can we move on? Okay, so I will take it as a yes. And now you will have to log into https vandb.ai/site and over there create a new VanDB account. So I already have an account. You can just go to VanDB's website. You can just type VanDB on Google also. Go to their website and say sign up. It asks for your email ID. You can just give in your email ID and create an account in Weights and Biases. And once you're done, you will have to create a new Conda environment with all of the packages that we want. So step number 6, I have a Conda create.
Please share your screen.
Oh yeah, just. Okay, here we go. I hope everyone can see my screen. I hope everyone is able to successfully clone your repository, clone the GitHub repository into CellStrat Hub. Create a new folder or directly on the root folder, clone this into Hub. Once you're done, you can visit VanDB's website and create an account for yourself. It just asks for your email ID. You can use this link, otherwise you can just Google VanDB and then it takes you to their official website and you can sign up and create an account over here. So sign up and create an account. And once you are done, you will have to create a Conda environment. Please let me know if all of you have created a VanDB account.
Yes, created.
Okay, great. Let's move on. The next step is on your terminal, you will have to create a new Conda environment. So Conda create, you can copy this entire thing and paste it over there. I'm creating an environment called MLOps, which uses Python, MLflow, Jupyter, Pandas, Matplotlib, and requests. So just take this and put it on your terminal. Wherever you are, just put it on your terminal and create the new environment called MLOps. So in between, it will ask you whether you want to proceed. So just click yes and proceed and install all the required packages. Once that is done, activate your environment, Conda activate MLOps and pip install WANDB. So WANDB cannot be installed via Conda, so we will have to do a pip install for that package. You can do a pip install, and finally, once you're done, you will have to log in to your WANDB account on your terminal. So say WANDB login, it will give you one link to authorize. So copy paste that on a browser and there will be a key and you can copy paste it back. So all the sub steps in step number 6 are kind of explanatory. You can just look at it and execute that. Let me know once you finish all the way till step 6.
So Aditya, you'll have to delete certain packs, I guess, or you can contact us offline if you want to be upgraded to the alpha beta pack for more space. So to delete the packs cleanly, I'm going to send instructions to create space. So how to properly delete the packs. There's a proper process of deleting a pack to make space. So I'm sending that that has to be done in terminal. So if you delete the packs, you will get space. The other option is you contact us after this workshop. We'll upgrade your account to alpha or beta tier. Monimoy, I was having the same problem. Monimoy, was your problem solved? Did it start? I was having the same issue.
Not back. No.
Okay, so I'm trying something in my account. I have the exact same issue what you have. So let's see if it is not resolved. We'll check with our AWS team later.
Okay, thanks.
Is everyone completed step number 6? Can we move to the next step? I hope everyone's Conda environment is installed and you were able to also authenticate it to WAN-DB.
I'm in last step. We have to put the authentication key.
Yeah. So, do you want to share your screen? There, on that page, you will get a website, like you will get a link. You will have to click, copy that, put it on the browser and get your authentication key to log into WAN-DB. Let me know if you can't do it. You can share your screen and I can help you there. WAN-DB is giving you errors. Can you share your screen, Prasad? I will stop sharing. Prasad, do you want to share your screen?
Can I share?
Yeah, go ahead. Okay, I think Prasad is sharing. Just give a minute. So where is this? No, WAN-DB. So go to your terminal. Why is WAN-DB giving an error? Yes. Not here. Your terminal, CellStrat terminal at Jupyter Lab. You are CD. Did you try the? Did you do that Conda install all the packages? You can copy that from instructions. So you can open this in the left. There is this instructions, right? You can open that file. Double click on the instruction down. Yeah, that one. So step number 6A, yeah, you can copy that and paste it on the terminal. Backspace, yeah. This will kind of take some time. This will take some 3 to 4 minutes. Yeah, you're done. So no, there isn't. That's okay. Yes. Why? Yes. So Sukhbir, were you able to? Terminal is stuck in the last part. Okay, we'll see. Yeah, and just a minute. No, not here. Can you just 1 minute? Can you just Conda activate MLOps? Yeah, now try pip install WANDB. Okay, so now you will have to say WANDB login. So Sukhbir, you can just look at the screen now. Just a minute. When you say okay, when you say WANDB login, in the last but one line it is giving you, you can find your API key in the browser here. That last but one line, HTTP, yeah, that thing, put it on your browser. Copy and put it on your browser. And now, yeah, you can copy that and put it back in the terminal. Just Control V. Only once. You can't see it, so only once. Okay, yeah. So now you're good to go. Okay, so just a minute before you start training model, I just want to just wait a minute. So Sukhbir, do you want to share your screen?
Yes, can I share? Because in last
Yeah,
step I can't paste the
yeah,
key.
sure. You can share your screen now. Okay, so just a minute. Yeah, so click on that https wandb.ai. Don't click, copy that last but one line. Yeah, copy that and put it on a browser. Yeah, copy this. Good, not that one. Yes. Go back to, yeah, just once, only once. Control V, because you can't see that, but only once. Don't do it twice. And enter. Can you do it? I think, I'm not sure. Maybe you're doing it twice. See, it was only 40 characters. Yours was 240. So just click your browser there and just do Control V only once. If you do it multiple times, no, it's already copied on the clipboard. You have done it multiple times. That's the reason. Just do Control V only once and enter.
I'm doing in one time, but not showing the pasted to your key.
Yeah, it won't show. It won't show. Yeah, it won't show. Just press enter. If you have done it once, press enter.
Again showing error in terminal.
No.
Now done. Yes.
Done. Yeah.
Pending
It
key.
won't show it over there. So now done. So can we move to the next step if everyone is done? If all of you are done, can we move to the next step? I will take that as a yes. So let me just share my screen. Okay, just please listen carefully. I'm just making a slight deviation from what is there on instructions because that is going to take quite some time to run. So now navigate to the main project folder and step number 7. Now we are executing step number 7. Navigate to the main project folder and execute the below command in the terminal. So you will have to find out where you are. So look at this. I am not in the right folder. So you will have to go to the correct folder. So over here again. So I will see what all folders are there, and MLOps workshop is my folder. So navigate to that folder. And again, so this is the folder. If you can see, this is the folder where you have your ML project, your README, your Conda and other things, instructions and everything is there over here. Please listen carefully. You will have to navigate to this folder and just say MLflow space run dot. That's all. Because MLflow, I will just copy and paste it there because I don't want to tune any hyperparameters as of now. That is going to take quite some time. I will just paste this on chat. MLflow space run space dot. I will just execute this and it is going to take a while for your program to run. Let me know once you have completed this step. We can go through the code to understand what exactly is happening. Everyone is able to successfully complete step number 7.
Yes.
I hope everyone is able to complete. So let us, that is going to take a while to run before you can see your results. So in the meanwhile, let's kind of quickly go through our code. So this is where our code is. And you have your conda.yml. As I told, for orchestration, you will have to follow a particular folder structure. You need to have an ML project. You need to have a main program. You need to have a conda file and a config file if you are having a lot of hyperparameters. So conda file and ML project are all similar to before. Let's look at our config file over here. So our config file has lots of hyperparameters and it's organized in the YAML format, which is similar to JSON. So for ETL, there is some ETL that is happening. This is the input file that you have to take, and there is a minimum price and maximum price, which we are keeping. This is the project name and the experiment name that you have. And for modeling, you have a lot of hyperparameters like test size, validation size, and a seed. And for the random forest is using a lot of default hyperparameters. So using Hydra sweeps, you can give a range of hyperparameters and run it for each of these things. So this is about our config file. Let us look into what is happening in our main file. Main file has a lot of steps, like it has download, basic cleaning, EDA, data split, and all of these things. And within the main file, this is how we are orchestrating. So for the download, you will mlflow.run, run the download component or the get data component. It has its own set of hyperparameters that you have to pass. To do the EDA, you mlflow.run, call the EDA component, and this is the set of hyperparameters that you have to pass. And you have basic cleaning. You will do a lot of basic cleaning. You can write code yourself to do the data check. Data check, we can kind of incorporate PyTest, as I told before, to do all the deterministic and non-deterministic data checks. Then you have what is called as data split. So input, test size, random size, and stratify. And finally, our train component of the program. All of the config that you have, just bring it into a config and pass it in as a parameter into your program. So if you see, components over here has got multiple folders: get data, train, while, test, split. And your source over here has also got multiple things: basic cleaning, EDA, and train random forest. So each of these things you can go through how it is working, but I will go through the train random forest over here to understand what exactly it's doing. So within your trained random forest, you will get all of the configurations that you want, and you will read your file, you will create your X and Y, and you will split it into your test data and validation data, and you will create your pipeline over here. So there is a, if you scroll down, there is a huge code to creating a pipeline, and you will create that pipeline over here, and you will do some kind of scoring. So R2 score is what is being, R squared score is what is being considered over here, and you will log that info and save that model into, you will be saving that model as an artifact inside your weights and biases. So if you also scroll down over here, see run.log, it is logging your feature importances. It will create an artifact and add that. And all of your parameters that you have, that is also being logged. I'll just show that to you. So you will be creating your pipeline over here, calling the random forest. All of those things are incorporated in your pipeline, and you have to just call your program to run this entire thing. So similarly, you can also go and take a look at how EDA is happening. EDA is pretty simple. It's just creating a table, and basic cleaning is also removing duplicates and some other such cleaning that is happening. But over here, if you look at your main.py file that you have, this is where you're orchestrating all of the different steps. Let us take a look at where our program is. As I told, this is going to take some time to run. In the meanwhile, I can also show you the output of the program that I completed yesterday. So MLOps workshop was the program. So different job types have been defined, like test the model and train the random forest, basically in download and train evaluation. So you can go to your artifact, and you can see that all of your artifacts are there over here. And I did a lot of hyperparameter tuning, so I kind of generated 8 models over here. So 8 models are stored over here. And if you go to table will give you it will give you the table of all the runs that you have. So basically, these are your R2 scores that are there. I tried with multiple estimators and maximum depth over here. So for each of these things, it gave different values of R2 score. So what you can do is you can kind of sort this by descending to find out which is your best model. So this is your best model, and you can mark that model as the final model to be put into production. I will pause over here for a minute to take any questions. Any of you have any questions with either the code or with any of the concepts that was explained?
Hi Shubha, this is Shreyash here.
Yes. Yeah. Hey, Shreyash.
Yeah, so this what we are doing is mostly for training orchestration, right?
Correct.
Yeah, so this use case would be mostly like when there's some trigger in the overall, right?
Correct. So as I told before, there are 2 more components to this, which I have not explained today due to time limits. It has to be probably covered in the next session. This is more or less the MLOps thing that can be used by data scientists. So all of these things are experiments that will be used by data scientists, and figuring out which is your final model and marking that model for production is the final task of a data scientist, and that's when you hand it over to the ops team. So probably in upcoming sessions, what you'll have to do is you will have to think about writing your CI/CD pipeline to orchestrate, to continuously integrate it and deploy it from your GitHub repository. And also there is another concept on model monitoring, where you will have to try and monitor your model in development or in production and kind of build the pipeline for retraining. But yes, this is just the first part of the entire cycle. You have to automate your CI/CD, and then finally you will have to monitor your model.
Okay, so when you deploy this won't be the ideal thing to do, right? I mean, in terms of using MLOps, there would be like CML, continuous ML, and all those.
That has to be, yes, that has to come along, and that has to be integrated along with this.
Okay, so this is mostly for the development stage of any project, is what you're saying.
Development or data scientist phase, I would rather say, because these are the tasks that you are doing as a data scientist, and as a data scientist you cannot use Jupyter notebooks to do all these tasks. So you will have to come up with some way where you can track your experiments and analyze them and try to figure out which is your best model. So this is the MLOps, that the first part which can be used by data scientists. Then MLOps engineer, once you put the model in the model repository, that's when MLOps guys will pick up that model and build a scalable infrastructure.
Okay, I mean, one more thing is that MLOps also, MLflow also has that hyperparameter tracking and all the...
Yes. All artifact storing, experiment tracking, and everything is there with that. It also is there in Comet and Neptune also. But the idea is, if you try to understand how it works in one of the tools, it is easy to... You have understood the concept, and it's just a different set of APIs that particular company gives, and it can be implemented in whichever package you want. So this is just
like, that is correct. So then my question is like, why WANDB is only for sharing between the colleagues your hyperparameters, because that also is supported natively by MLflow?
Correct. You can use MLflow. As I told, when I discussed about alternative approaches, you can use MLflow and do the entire thing in MLflow. You can do the experiment tracking, storing artifacts, all of these things in MLflow. And so WANDB does not offer orchestration. That is why MLflow has come in for orchestration, and WANDB is used only for artifact storing and experiment tracking.
Okay, because mostly in my team, they don't trust sending your parameters to cloud, external cloud. So the WANDB is mostly not used. So that's why you use MLflow. So that's the thing.
Okay. But yes, different tools are available, and you can pick whatever you want. But the overall high-level concept is the same.
Yeah. Okay. Thank you.
Let us look at where our program is. So as I told, this is going to take some time. Can I get a heads up from audience on who are all trying it, and if it is still running for you? Okay, I believe that you are trying it out. You will be able to. Okay, great. I get some answers over here. You will be able to visualize the results yourself on WANDB once your program completes. So seeing the results for yourself is going to be great. So I urge you to try it out. Meanwhile, while the program is running, we can look at the last part, which is deployment. I was not able to serve the model on CellStrat Hub. However, I was able to do that on my local laptop. So I will just show you a demo of the same. The final part, deployment, this is just to conclude what we are doing today. But generally, deployment is not the task of data scientists, as I told. You have to just mark your final model in production and hand it over, put it in a model repository and mark it for production. And there ends the task of the data scientist. That model has to be picked up by the MLOps team to be deployed in a scalable way. So, but then deployment, you can just create a simple endpoint and try to test for new predictions. So model serving is to host your machine learning models either on cloud or on premises to make their functions available via an API, which can be incorporated. So within MLflow, though I have included the instructions over here, I have included the instructions over here, and you can quickly try out the deployment. So the model that I choose to deploy is on see, this is WAN-DB artifact, and get that particular artifact. So I have model number V4, and I will be getting this model out and storing it over here. So you will have to get this model and store it in your local folder, and you can do MLflow model serve -m. So if you can see over here, I tried it some time back, and I have this over here, MLflow model serve -m, and an endpoint has been created, and this model is serving at this particular location. So I can write a simple program for that. I can go to predictions over here. And I know that my model is serving at my local host. So when I try to run this MLflow model serve at my local host, the model is serving at this local host, and it is giving me the IP address over here. So I use that, and I post my data over here, and you will be getting your predictions. So I have included these two steps on the instructions in case you want to. All that you have to do is change the name of the model that you want to market for production, and you will be able to serve that model and make predictions on top of that model. And as a final step for release, what you have to do is you will have to mark your project as for release. So what you do is you go to your repository over here, and you have releases. So you go ahead and create a new release. So I have called my release as 1.0.0. The naming convention will be the first letter 1.0.0. The last 0 is for any bug fixes. The middle number is kind of any enhancements that are backward compatible, and the first number that you have are for major enhancements that are not backward compatible. So you can add some tags over here, probably your version number and other contributor names, and mark your repository on your GitHub for release. So this is kind of a basic GitHub exercise. You can just Google on setting your project for release, and your project can be set up for release. Let's just give this a couple of more minutes, to some more time to see how this is, and wait for this to complete. In the meantime, if any of you have any questions, please do ask.
I think pretty extensive hands-on workshop. My account got stuck personally, but I hope some folks were able to do all through.
Okay. You can also simultaneously log into weights and biases and click on projects. By now, a project will be created for you, MLOps workshop project. So you can go and look at your results. I know that the program has not completed. It will take a while, but still you can take a look at what artifacts have already been created. So different job types are created over here. And if I look at this table, the R2 scores are there over here, different R2 scores that have been created. And there are some artifacts as well that's those are there over here. And in order to mark your project for production, what you have to do is figure out the model that has to be marked for production, and you will have to add a new prod tag. So over here you can just click on plus and add a new tag. So it is not necessary that it has to be prod. It can be whatever your organization wishes to follow. Maybe if your organization wants to call it as release, you can add a release tag. So the team will be taking up the model with that particular tag, which will be used for deployment and inferences. So based on the score and the experiment tracking that you get over here, you can sort by descending based on your evaluation score and pick up a model which you feel has to be the final model, and go to artifacts, and you can just give it your latest tag, or not the latest tag, release tag or the prod tag. So if you want to test the model that we have just created using the next step, I suggest that you give it the prod tag, because we will be using the prod tag to test our model. So let me know if the program completes for anyone.
Shubha, can you just walk through the sequence once, like when you first run MLflow run dot? So
Sure.
first reading the ML project file, right? And
yeah, so let us just go through that. So you can pass in steps, and you have Hydra options over here. So all of the parameters that are there in config.yaml file will be passed. So if you look at this is the entry point. So this is the folder where we will be using ML run dot. And so this is your entry point. You will be running main.py. Pardon me?
So it's like same like format like Docker file, you have right, entry points and all that.
Correct. You have your entry point, so main.entry point, and so once you start ML project run and MLflow run dot, it is going to start at the entry point and run this command. So it will run your main.py file. So I will close everything else, and let's look at what is in the main.py file. Within the main.py file, you have to add this decorator. When you add this decorator, your config can be used directly. So it can just be used like config etl sample. So all of the parameters that are available in config can be directly used. So over here, what will happen is, if I just have all the steps defined over here. So if the steps are there, you will do mlflow.run and run each of these steps. So the first step to run is in the components folder, get data will run. The next step is in the source folder, EDA will run. In the source folder, basic cleaning will run. In the components folder, train val test split will run. And finally,
and each of this folder has that ML project defined, right?
Yes, correct. So then your source file train random forest will run. Okay, so let's just look at a few simple ones. First one is components and get data. So you get into components and see the root path over here. Root path is my current path that I have over here. So the root path is, I'll get the current path from Hydra. From that path, components and get data. So I'll get into get data over here. This should have the same format. You have a conda file, you have an ML project file, and you have a run.py. So if I look at this ML project file, it has some parameters will be passed to that. All these parameters will come from here. Yeah, parameters are needed for get data. No, sample is from where do I get data and what should I call that artifact? What is the artifact type and all those things. So when you're calling this get data, these are all the parameters that you pass. And when you go back here and see, this is ML project of get data, Python run.py, you have to pass sample, you have to pass artifact file name, artifact type, and all of these things are passed. And these things you will get it from by passing those parameters here.
So it is creating
So
another Conda environment here, like this.
Yeah, it is. Yes, it is creating a Conda environment as well because okay, fine. Maybe probably here we need requests library, or you are trying to do some EDA, you want pandas library, and in your random forest thing you need sklearn library. So this pandas library is probably needed in this get data, and you have to give pandas. If in your random forest, you need the random forest library and you do random forest. So there is a Conda environment as well that gets created. So if you look at our runs over here, every time every time it says ML projects run ID, it is creating one particular run ID and it is creating a Conda environment. So in whichever step it is in whichever step we are in, it is creating a Conda environment in that particular step.
Can we change it to reuse the same Conda environment somehow?
Yeah, now if I run it for the second time, since we are running it for the first time, this program is taking so much time. But if I run this same program for the second time, it's going to run very quickly because all the environments would have already been created. It is going to run very quick. This is taking so much time only because we are doing it for the first time. And this is your ML project. So if you look into your run.py within get data, this is pretty simple Python code. Initiate WAN-DB run and just get your artifact and add that artifact, log that artifact and put it back. So this is get data. So this is just, we have a sample file or a data file that's stored either somewhere in the cloud or in your local. You're just logging it as an artifact file into WAN-DB. So this is the first part. So if you, then probably your next part will execute, maybe train test split. So if you look at that, that also has the same structure. You have ML project, you have conda.yml, and you have a run path. And this run path will fetch the artifact from WAN-DB for the data that you got. And on top of that, it will do cleaning or EDA or whatever, or it will split it into train val. So if you look at ML project over here, again, you are running the run, you need an input, you need a test size, you need a seed, and you need stratify by. These are the parameters that you pass. If you look at your main project over here, this is basic cleaning, data split. If you look at your main project over here, you need input, you need test size, you need seed, you need stratify by. So all of these things are defined in your config environment. So in your config environment, get all of these parameters, pass it, and call your train val test split. So that is going to call your train val test split in MLflow, and this will run this program by passing all those parameters, and it will do train val test split and put the train data and validation data into WAN-DB. So similarly, all other components are integrated and it kind of chains up.
Okay, so do you think like we can create a template using this project?
Yeah, I created something using cookie cutter. So yes, you can use cookie cutter or something similar where you just create one template and then reproduce it for multiple things.
Okay, I'll open a PR in your repo only, so try to do that. Yeah, this is quite interesting.
Yeah, sure. You can just fork the repo and try it out yourself.
Yeah, I'll be trying that. I think the last step we can add is like deleting all the Conda environments, multiple, something like that.
Probably clean up, yes.
A cleanup step. Okay.
Correct.
Thank you.
So Shreyash, were you able to try the demo on CellStrat Hub?
I'm trying locally, but not
Okay.
right later.
Okay, but is it working locally?
Yeah, locally it's fine. It's
Okay, but there is one thing that I wanted to tell. If you're using Hydra, it might not work if you're having a Windows system. It works only on Linux systems if you're using Hydra. And if you wanted to work on Windows, you might have to install that WSL or Windows subsystem for Linux, something like that to install and then do it. Otherwise, MLflow will not work on Windows. You will have to directly run the Python file yourself. Like this run.py is there, no? You have to directly say Python run.py. But it will take all the parameters from Hydra, but MLflow run. In the first level might not work if you are directly trying it on Windows system. Otherwise, you can do it on WSL.
okay. Fine. One more thing, like if you wanted to create a Docker file in the end, like the one more component, that can also be done right in this.
I think so. I have to really read up on Docker. I'm not very familiar, but yes, I believe it can be done.
Okay.
Okay, any other questions, audience? So Shubha, I guess we need a set of webinars of this kind, right? So there's seems like a extensive set of topics. So you said this was
Yes.
part 1, so there'll be another part, I suppose.
There has to be part 2 and part 3. Yes, it has to be there because part 2 will consist of automating the CI/CD pipeline. Automating the CI/CD pipeline will be as soon as you check in your code into GitHub, this entire process has to trigger. We should not come and run it somewhere. It should be like you just check in your code into GitHub and it has to start running. And third part has to be about monitoring. Monitoring is a very important concept in large-scale production environments because it might not work. So monitoring also is an important concept of MLOps, which we have to cover.
So is there a dependency on having done this part 1 webinar to go to part 2 and part 3 then?
Not necessarily, but it is a good thing. So part 1 is more or less for data scientists. These are the tasks that a data scientist will do. So orchestrating this process is for data scientists. Part 2 and part 3 will mostly be for MLOps guys or ML engineers. They are the ones who have to build a scalable environment and deploy it and build that automated CI/CD pipeline. So, but yeah, it is an integration, and at a high level, it is good to know both concepts. So yes.
I had a career-related question. How long it takes a data scientist to become MLOps expert, and also how long it takes a DevOps or cloud expert to get into MLOps?
So Vivek, from my experience, the toughest thing is a data scientist because understanding those algorithms is like it takes the longest time. Other things are all like they are all just APIs or set of processes that you need to know. It's not, there is not any kind of in-depth understanding. It's just it is a set of process and best practices that you have to follow. So if you're a data scientist and you have good knowledge on ML/DL algorithms, this is kind of really simple. But the other way around might be kind of difficult. If you're
What
a
about
DevOps
folks coming into MLOps?
So they will have to understand normal DevOps just has CI/CD pipeline, but over here we have to understand the concept of training as well. So continuous training. It's not only integration and development, it's also training. So they need some ML knowledge. They need to understand how an ML system works, and how you train and you give a model or something like that. You put a model and then there is some amount of, there is a difference between DevOps and MLOps person. So they need to have some knowledge on data science. So yeah, I think Shreyas was saying something.
Like I have seen people like 3 months transition DevOps to MLOps, and so I mean, can be done.
Okay. So one more feedback. See, we are into enterprise solutions now, but most of our customers are small and medium enterprises. So we don't see a need for extensive MLOps there. We are giving ready-made, small models, AI as a service. So the MLOps concept seems to apply to larger ML environments, not to small and medium solutions. Am I right?
Yes, that's right. So yeah, most organizations for that matter, except some big companies, they will all be trying to see how AI fits into their company. They'll be trying to do some kind of POC or analysis or something like that. So in most of those scenarios, they will not need a large-scale MLOps team and the entire infrastructure. It's only like when it is completely stabilized and it is in production being used by multiple users, only then you need to have a very strong infrastructure.
Okay.
It's good to have guardrails in place already, because otherwise later it becomes very difficult to introduce this.
Right.
Yeah, kind of the way we do POCs in data science to see if our model fits, how well it fits the data. You need to do POCs in MLOps to see what kind of an infrastructure you plan to build. So you will have to do a few POCs to understand your infrastructure and then decide.
Okay, so any final questions, audience? In interest of time, we'll have to wind up. Any final quick questions? So I think Prasad was asking something, not sure.
We can tend to forget. So run all the steps once from the beginning as you. So run all the steps is the overall objective is you have if you have kind of built a small data science POC for your company, or if you have participated in any organization, competition, you will realize how easily things can get messy if you are using Jupyter notebooks. So it is a better way of writing code. This is kind of a better way of writing code where you orchestrate the entire process. You cannot have EDA in one notebook and feature engineering in one notebook and model building in the second notebook with different hyperparameters in the fourth notebook. So having all of these things and placing them in a cloud-based repository for you to later on revisit the work that you have done, and also help you in analyzing the different experiments that you have run, is the main background behind MLOps. So today's session, to summarize, we are trying to understand how you can use some of the tools that are available to kind of orchestrate and bring this entire process in one place and streamline the entire process so that you can build more reproducible code, which is going to help you better do your POC. I hope that answers your question, Prasad.
So with that, I think we'll conclude this. Thanks a lot, Shubha. Very extensive presentation and hands-on activity as well. So I will look forward to your next session in this series.
Sure.
We'll share the recording on our YouTube channel soon.